Lithium-ion batteries power almost everything in our modern world. Your smartphone, your laptop, electric vehicles, even large renewable energy storage systems. But here is an important question. What happens if lithium becomes too expensive or too difficult to obtain? What if the future of energy storage depends not on lithium, but on sodium, an element we can extract from seawater? Today we are going to explore whether sodium-ion batteries could replace lithium-ion batteries, and what that means for the future of energy. Lithium-ion batteries dominate the market for good reasons. They offer high energy density, long cycle life, good efficiency, mature manufacturing infrastructure. However, several challenges are becoming increasingly serious. First, lithium reserves are geographically concentrated in only a few regions. As electric vehicle demand increases globally, supply chain risks become more significant. Second, lithium prices have fluctuated heavily in recent years. When lithium prices rise, battery costs increase, and that affects electric vehicle affordability. Third, lithium extraction, especially from brine sources, consumes large amounts of water, creating environmental stress in some regions. And finally, there are safety concerns. Under extreme conditions, lithium-ion batteries can undergo thermal runaway. Because of these challenges, researchers worldwide are actively exploring alternative battery chemistries, and one of the strongest candidates is sodium-ion technology. Is sodium-ion a powerful alternative to lithium-ion? Let's see. Sodium has several remarkable advantages. It is the sixth most abundant element in the Earth's crust. It is widely distributed across the globe. It can be extracted from seawater, and it is significantly cheaper than lithium. From a resource perspective, sodium offers stability, affordability, and global accessibility. But abundance alone does not guarantee performance. The key scientific question is, can sodium store energy effectively? Despite their promise, sodium-ion batteries are not perfect. The most significant limitation is lower energy density. Lithium-ion batteries typically achieve around 150 to 250 watt-hours per kilogram. Sodium-ion batteries currently offer lower gravimetric energy density compared to lithium-ion batteries, primarily due to higher atomic mass of sodium, lower redox potential, and structural limitations in host materials. Therefore, sodium-ion batteries are not ideal for applications requiring maximum energy density, such as long-range electric vehicles. Sodium-ion batteries operate on the same fundamental electrochemical principles as lithium-ion batteries. They consist of a cathode, an anode, an electrolyte, a separator. During charging, sodium ions move from the cathode to the anode. Electrons travel through the external circuit. During discharge, sodium ions migrate back to the cathode, releasing electrical energy. However, there is one critical difference. The sodium ion is larger than the lithium ion. This larger ionic radius leads to slower diffusion kinetics, greater structural strain in electrode materials, lower theoretical energy density. Because of this size difference, material engineering becomes extremely important in sodium-ion systems. Researchers are developing advanced cathode materials such as layered oxides and Prussian blue analogs, and anode materials like hard carbon to overcome these challenges. I will discuss the working principle of the battery in another video. Despite their promise, sodium-ion batteries are not perfect. The most significant limitation is lower energy density. For applications like smartphones or long-range electric vehicles, this can be a limitation. Another challenge is the larger ionic size of sodium, which makes intercalation into electrode materials more difficult. Additionally, electrode material optimization is still an active research area. However, progress is rapid. With advances in material design, nanostructuring, and electrolyte engineering, performance is steadily improving. Do you want to explore energy storage systems, advanced electrode materials, corrosion science, electrocatalysis, and the secrets of electrochemistry? Then this channel is for you. Subscribe and join the journey. See you in the next video.